Ο κύριος Σαμ Καλίλ είναι καθηγητής στο Τμήμα Μηχανολόγων Μηχανικών στο Πανεπιστήμιο του Καΐρου, με περισσότερα από 40 χρόνια εμπειρία στο σχεδιασμό και την προσομοίωση των θαλάμων καύσης για επίγειες, χερσαίες και αεροδυναμικές εφαρμογές. Έχει δημοσιεύσει πάνω από 550 άρθρα σε επιστημονικά περιοδικά και πρακτικά συνεδρίων που αφορούν την καύση, την ενέργεια και τον έλεγχο της ποιότητας του αέρα στους εσωτερικούς χώρους. Διδάσκει μαθήματα που αφορούν τη μεταφορά θερμότητας, τους καυστήρες αεροστροβίλων και την ενέργεια.
Good morning, ladies and gentlemen. Thank you very much for giving me the chance to be here. I have a long presentation, so please bear with me, but I'll be on time. As a designer of air conditioning systems, we like to keep these lungs running, provided with fresh air, clean, at the most efficient energy-wise. Since I'm from Egypt, and Egypt and Greece are very close friends, allies for a very long time, I thought I'd put this slide just to remind us of our joint history. The question which should be asked now, can we make a difference in our life now? And the answer is yes. So let's go to our baby or our concern, which is the energy in buildings. In a building like that, where we think that we have green buildings, we should consider all the factors that relates to making it efficient. In the committee that I chair with ISO, that's International Standard Organization, we are designing standards for how to manage and build energy efficient buildings. This is one of the standards, which is standard 23045, which was out. And it relates the various sources of energy, new and renewable, as you can see from the graph. And here that's the energy inputs and energy outputs. If we take a sample in any typical building, we have passive systems that we'd like very much to maximize. These are the systems that don't use energy. And this is the responsibility of the architects. Orient the building, use the building fabric, thermal mass, insulation, daylighting. But also some of the systems that are active, they use a lot of energy, like heating, cooling, and air conditioning. And we'd like to minimize that. Surely, all the time, we'd like to use renewable energy because it's free. I like this. This was my exam when I was elected to be the deputy director for the American Institute of Aeronautics and Astronautics. So to show leadership, this is the carrot. And it's been driven by people, and it contains tires, and it has square wheels. So in many places in the world, we are like this. This is not good, because always round wheels are on the wagon. They are burden. They are not used. While the round wheels of today will be the square wheels of tomorrow, which means that we are always developing, we are always expanding, we're always improving. We should use this and innovate all the time. Now, the one at the front of the wagon sees this beautiful future, but the one at the back sees nothing. He's just pushing. I'd like that we change this. So how the world will be without engineers? Chaos counting. Now, in what are the benefits of having green buildings? We reduce the cost, we reduce the waste material that which we throw away, and we reduce also the carbon dioxide and carbon monoxide that we pollute the world with. In Egypt, where I come from, we had our green building ratings, similar to LEED, BREEAM, and others. And the aim of these are to provide benchmark and to enable us to have better buildings. And these are legislatives, these are codes and standards. If we look at the levels, we have the certified, the silver, the gold, and the green. And we have credits. If you do a building where it's respecting the environment, then you get points. Let's see how the points go for. Sustainable sites, using and respecting the society, gets good marks. Energy efficient also gets about 30 points. Water efficiency, which is very important. Actually, now we have the energy and water nexus. They are completely related to each other. And the trend is to conserve both of them. Material and resources. It is good to build with local material rather than to import material from another site, which means you're using carbon, you're using fuel. And we had to consider this when you are getting your building constructed. Very important, indoor air quality, thermal comfort, visual comfort, acoustics are among the very important factors when we are designing energy efficient buildings. Management is a good trend. Now, the thing that I'm advocating is innovation. Without innovation, we are lost. We have to let people innovate. Without new ideas, we'll keep standstill. So the objectives are to have a better building and better performance. Site selection, accessibility, ecological balance. Minimum requirement will be for site selection. We have, this is I'm just going through quickly for the point system. Also for the selection of the materials. We have to use renewable materials, recycled materials, not to do a lot of waste material. So these are the points for the mandatory minimum requirements. And in site provision, site environment, and so on. So if we go to the cultural heritage, yes, we have to preserve our culture, our archaeological places, and I'm going to talk about that later in my presentation, since I was doing a lot of work with archaeological places. Innovation is very important. So these are the minimum points for. Now, when we go to any building, like the one we are living in now, we have to use room automation to reduce the energy usage. If we are not in the room, then lights are switched off, air conditioning goes to a sleeping mode or something like that. This takes part of the initial cost, but they save money on the long run. This is why we have to run a life cycle cost analysis. So our goals will include that we do reduce the use of material, reduce energy, and carbon dioxide. Now, if we look at the this here, at the top, instead of using unlimited resources, let us call it precious resources. And instead of using distributed system, we do centralized. Instead of controlling, let us call it cooperation. And instead of consumption, we'll call it smart usage. So what's next? We have the International Green Construction Code that has been out in 2010, and it's been applied. It has a lot of chapters. I'm concerned with the chapter with the indoor conditions, temperature, humidity, and thermal comfort. In details, it considers the air conditioning in the room, temperatures, and so on. Examples are how to do this temperature control, how to do the air distribution in various situations. Also, ASHRAE 189.1, which for the high-performance green buildings. And if we consider any power requirements, then we need to switch the light. And to switch the light means that we operate a power plant. Power plants will produce carbon dioxide, carbon monoxide, volatile organic compounds, and nitric oxides, which are pollutants. and we have to reduce this. So that goes through the energy efficiency. We have primary energy going into the actual net energy. So the benefit of using codes and standards is to reduce the energy consumption. Building owner will have cost saving and will reduce the carbon dioxide emissions. So it all comes to the benefit of the tenants and the owners, and we perform what we call life cycle cost analysis, which is becoming not fashionable, but mandatory now. You cannot build anything without really evaluating the savings against the systems you are using. For example, in building envelope, would we use double insulation in the outside facades, or what? In the Gulf area, in the Arab countries, we use single wall. We don't have insulation. In Kuwait, they start having double and insulation. In Dubai as well. So it's a question of the construction trade, whether they use a double insulation or a single insulation. We have to consider this. Heating, ventilation, air conditioning, these are some of the projects that I designed. It's a 20,000 ton refrigeration district cooling for a university campus in Egypt. So we use absorption chillers, we use cooling towers, and we try to make as much as possible of energy saving. Of course, we use compact fluorescents everywhere to save energy. And actually, the governments, they give bonus for the people. If you use compact fluorescents, your energy bill will be reduced, and we can give you the lamps free. Also for the water heating. Now, also for the committee that I have the pleasure of chairing for now 10 years, it's ISO 205, we devised this design standard for systems. And it was led by Professor Kimura from Waseda University in Japan. And it's out yet, it's called ISO 16813. And it lists to you how to design a system. What are the requirements? You have to give a calculation, load estimation, documents, design procedures, design documents until you are out. Since I'm from Egypt, I like pyramids. And we made this, myself and Dick van Dyke from Holland. We proposed this in 2009. It's like the energy pyramid. And we see what the energy performance indices are required. And from that, we see that boundary conditions, energy elements, and what are the rules and regulations. So these are listed out in the paper if you like to read it. Now this sums up the systems we have. We have the heating, lighting, ventilation. This is typical. I've seen this before, of course. And this is a joint work between 163 and 205. These are ISO committees, technical committees. And we'd like to do some of the energy production from renewable energies. And it's becoming now a fact in Germany, at least, where people put power into the network. Now, for energy efficiency, we need these labels. We need labels to tell us if this is efficient or not. Usually now, the international trend is for 7 grades. So it goes from A to G. A will be the best. A will be the most energy efficient systems. And so on for each equipment, like air conditioners, washing machine, refrigerator, or even building. We rate them this way. Now, this is in Europe and the US. This is in Egypt. I'm sorry, it is in Arabic, but it meant to be in Arabic. Okay? I did this in 2006. Oops, but in 2013, I was not liked. I'm not popular because I raised the level of the energy efficiency. Of course, the manufacturers want to fight me, but it is good for the business. When you raise the energy efficiency ratio, it means that you get a more efficient equipment, means that you are going to force the manufacturer to improve his compressor, his system, and that, of course, saves energy for us. It means more investment in the technology development. So if this young lady is trying to climb up the stairs to the function or to the goal of indoor air quality, she had to go these steps. One of the steps is not clear yet. which is the air movement. See, my friends here, air comes from the grills, air conditioning, and goes to all of us to make us comfortable. Then the air goes out to the machine again. We would like to make sure that this air makes us comfortable, because this is a function before it goes out. We call this air movement efficiency. I'll give you examples. I have the pleasure and honor to do the design of the Grand Mosque in Mecca. Grand Mosque is a mosque, a place where we worship, and it houses the new development 1.5 million person. So the question is, where to put your supply air to make sure that the air which you pay money to cool down will be efficiently utilized. So we do some calculations. We do what we call CFD, computational fluid dynamics. My colleague, Professor Fuad, will be talking about that later today. So we have to take a sample of the pure human being and model that in various areas. And for example, at the level of 1.8 meters, what are the temperatures and what are the comfort levels? Let us take another example. This is a church which is called St. Mary's Orthodox Church in Egypt. It is built and on the spot where Christ, baby, and Mary spent few nights. So it's an archaeological monument, about 1,500 years old. And I had the honor to be the designer of the air conditioning for it. So to do that, it's a great honor. But also you have to be very careful. So we did some experimentation, we did some computation. So this is the shape of the triple vault church. This is some of the velocity, because I proposed to have the air. I'm not allowed to touch the building. So I had the ducts hinged like that, and goes from the natural opening in the ceiling. So nothing has been done, because this is the degrees of freedom. You're not allowed to touch the building at all. So that's what we did. And we use this robotic system that goes up and down and measure the temperature and relative humidity. These are some of the comparisons between the measurements in the church and the predictions. After we finished this, they allowed us to put the design, to put the construction, and it's working now for 2 years, to my happiness, of course. Also, for example, another monument that we have to do properly is a stadium in Qatar where you're going to play the football in 2020 something, and 22. So I'm doing the air conditioning design. Imagine a stadium with no roof, and you still have to air condition it, energy-wise. So we did that. We did some calculations, some computations, and it is working. The design is being implemented so far. So we had to go back and do some PMV, predictive mean vote, and thermal comfort calculations. So this is some of the samples of the results we obtained. We had to do some architectural change, structural change, by adding this curved bit outside the stadium to deflect the air, because the wind speed there is very high, 12 kilometers per hour, plus temperature is 46 degrees centigrade, relative humidity 70%. Oh my God. So you can imagine your thermal load. But, as engineers, we have to face the challenge. Another challenge which I've been working with for the past 30 years is operating theaters. So in operating theaters, you have the patients on the bed, and we have to make sure that the air going around make him very comfortable. So for example, that's an empty room, only with the bed. To the extreme left is the velocities, then you have the turbulence. At the bottom here, left, you have the temperature distribution, and then you have the humidity, relative humidity distribution. This is an empty room. We put the human being. You can see that directly yes, thank you. You can see directly here, because of the human being, the humidity distribution changed because of the perspiration from the mouth of the surgeon here. And these are the temperatures. Fortunately enough, the temperature at the ceiling is about 12.8, which is the off-coil temperature, 55 Fahrenheit. And when it goes to the table here, it's around 22, which is okay. So here now we put the operating light, and it disturbs the flow. So all these things are being useful now after we use CFD. So we need standards for our systems, and it is always the quality criteria is important. From the European countries, we have a lot of experience to learn, a lot of energy documents. Now we have the APPD, which is out and is being enforced. I think to have an umbrella document that is, we hope it will become an ISO standard later this year, next year. So these are samples of the. Now I go to a subject which is very near to me and very dear. I've been asked to design ventilation systems for 5,000 years old tombs in Egypt. And I'll show you why they called us. This is the photo of one of the Egyptian queens, and it is 5,000 years plus 25. It's not very good. That's how it looked like 25 years ago. So deterioration in the paintings are becoming very catastrophic. Why? Because of human activity. People go to these tombs, like the Lascaux cave in France, and perspiration, water vapor is produced. All the walls of the tombs are made of limestone. Limestone loves water. So when you go and human activity, then naturally these paintings deteriorate. And so these are 5,000 years old paintings. So my job was to calculate how many visitors I should allow in any tomb. So for example, a tomb comes from here, and this is the sarcophagus here. And you can see these are the relative humidity. Here is good, this is bad. This means that the relative humidity is about 70 or 80%. So if you put 12 visitors, you can look at the color. Here, this one is bad because it is more visitors and naturally more water vapor. That's another catastrophic one. This is King Tutankhamun, King Tut, the great king. And so the tomb, you enter from here. You can see the visitors. These are the visitors here. You enter from this short corridor, and here you have the space, and the sarcophagus is here. And these colors are the scale of relative humidity. So here, this is dark. It's about 80%. Yeah. So 80% relative humidity means that you have a probability of condensation on the wall. I really do that and get warm. So they asked us how to design a ventilation system, which we did. And it takes time just to implement. I'm working on this project with my colleagues for now 9 years. So if you put more people, you'll have higher relative humidity. You can see, if you look at here, there's less people here, you can see. If I push this, I add more people, or imagine more visitors, then it's not as good. And so on, we recommended for them only 25 or something visitors per one time. Of course, the government doesn't like that because they cash dollars for each visitor. And I think it will take some time until they go to what we... This is a movie that we prepared by Fluent about the tomb. You can see that everywhere, if you look at here we are going to show the profiles of, this is relative humidity. You can see the corner where you can have very high excessive humidity. I have more films along this line, but there's no time, and I see that our young lady here is waving her hands that I should finish. So I think I should finish this film and then... Oh, this is the recent work we did in the museum in Cairo. We are doing dynamic simulation of the visitors here moving around the various windows where we are putting the monuments, the small articles, and maybe next time when I see you, I'll be able to show a better. This is me, and of course this is my beautiful cat. He sits like that for hours, and I think he realized my work, but I discovered that he's only looking for the mouse. So he's there. And I'd like to thank my associates, assistants, research, who really, when I say I did, it's not me. We have a group of about 30 associate professors and assistants and research who are really patiently working with me. I'm a slave driver in a way. So I'd like to thank you very much for your patience. And if you have questions, usually people ask me, where is the hand? Because you see this guy, he has only no hand here. So I always say that, yes, I have two hands. Thank you very much.
Thank you, Mr. Khalil. Υπάρχει κάποιος από το ακροατήριο που θα ήθελε να κάνει κάποια ερώτηση? Are there any questions?
Thank you. Thank you for your great speech. It was very interesting. Moritz Schubert from Solid in Austria. You showed this stadium in Qatar, which was really impressive. I think the task to cool this. I have a question. What do you think might be the range of the thermal load that will be in the stadium, as it is not even a closed building?
Well, the load we have 460 jets along the stadium from the roof, from the small roof, and we have about 600 jets from the ground level, and the total cooling load is more than 20,000 tons refrigeration.
So it's around 70 megawatt?
Yeah. We offered to the clients to remove the floor, the field, and make cooling there. They refused. Because I think the solution for this was to do radiant cooling. They wanted this is a stadium that is already built. It's not a new one. So they wanted to do the minimum alterations. But I would think that using radiant cooling will be the ideal. I'm doing also another restaurant in Dubai, which is an open air, no roof at all, and we use radiant cooling. It's becoming a problem now in the Arab Gulf countries that we call outdoor cooling. People, not like you here, can enjoy sports in a nice climate. Because of the heat, they don't practice. They don't walk in a nice climate. So they discovered that this has a psychological impact on the people. So this is why they want to do what we call outdoor air conditioning or outdoor cooling. Of course, it's not energy-wise, but it's a necessity sometimes. So we'll wait and see how it develops. But this is my third project, like an outdoor. I'm not very happy about it from the energy point of view, but it's the client requirement. Thank you.
Υπάρχει κάποια άλλη ερώτηση? Okay. Thank you, Mr. Khalil.